Hi, everybody. So for this first lecture kind of video, I just want to ask the question and answer it for you. What is 3D and how are we thinking about it in this program? So 3D feels like a lot of stuff, but I want you to break it down to something much, much simpler. It's just points in three-dimensional space that are connected to each other. This train seems like a really complicated model, but on closer examination, when you can see all the wireframes, it's really just a bunch of points connected together to start to resemble a train. And our job as 3D artists is to move and create and destroy and manipulate and connect those points to generate models like this. Everything we do in this class is about moving, adding, removing, or connecting or disconnecting those points. Let's talk about what 3D space itself, though, is. So in especially different 3D programs vary. So for instance, if you're used to Unity, you might be a little surprised to see that Z is up. Different programs are a little different. Blender is a Z up instead of Z forward. So if you've used Maya maybe before, or even Substance Painter, another tool we're going to use in this class, or you've used Unity, you'll note they'll say Z is forward and back, X is left and right, and Y is up and down. Not the case for Blender. In Blender, X is left and right, where let's see, if we're staring straight on it, I would say like left is our positive X and right is our negative. Y is instead forward and back. And this is a little bit tricky in Blender, is this is actually forward. Negative Y is forward, positive Y is going backwards. So this little image here, this is going backwards, this is going forwards. And then the Z-axis is up and down. Now, in computer graphics, it's also very common to code these axes is three different colors. While you might be used to red, yellow, and blue as a model of color that maybe you learned in school, the color model we use for computers is always red, green, and blue, RGB. And we create these colors to correspond XYZ, RGB. So red is always the x-axis, and green is always corresponding to the y-axis, and blue is always corresponding to the z-axis. Now, within this space of 3D, we can move around a lot. So we have 6 degrees of freedom, meaning that I can move in any of these axes, so that's 3 degrees right there, and I can rotate in any of these 3 axes, giving me my 6 degrees of freedom total. Another thing that's really important in 3D modeling programs is we can also scale things. Size is indeterminate and it's relative, so we can also scale objects up and down in all 3 axes, X, Y, and Z. Everything in 3D space is an illusion. It is of indeterminate size and scale. In fact, you can see the little grid goes off in the distance because it disappears because there's no end to it. It's theoretical, it's mathematical, it's in a computer, it goes on forever. There is, however, a really important point for us to consider. At the center of our grid here is what we call the origin point. This is where everything is moved from. So if I take an object and I put it up in this corner, it is going to be measured in its coordinates of X, Y, and Z relative to that point. This point is 0, 0, 0 on X, Y, and Z. And that's our reference point for the scene. And it becomes really, really important for creating assets. Another rule to consider when we're in 3D space is what we're doing in this class is making 3D models for visuals. We're not designing bridges or cars. If your 3D model doesn't have airtight geometry, nobody's going to die. The rule here is if it looks good, it is good. We just want stuff to be nice looking. So often we cheat stuff and we get close enough when it comes to 3D modeling, as opposed to the kind of precision you might need out of, say, a CAD-based class. So what is a 3D model? A lot of you probably think about the 3D models as this kind of thing, the visual part, the geometry as we call it, but that's just one piece. That's what we call the mesh or geometry. Sometimes you might be calling it a model, and you'll hear people call them models as well, but I want you to start thinking of the model as like a larger container for all this stuff. Now I'm gonna move my head down again. So in this case, we see this little monster guy, and this is the mesh that defines his shape or geometry. But we don't know what he's made of, and he doesn't really move or interact in any way. Now, in order to have something that he's made of, we need what's called a material. I'm gonna move my head again. A material is the object that something is constructed out of, just like a material for like wood or steel. So in this case, we see the surface is reflecting light to show that he's green. Then he's got kind of a slimy mouth, and the rest of him's relatively rough, and he's got these beady little eyes. The material changes how light reflects off the surface, giving us color, as well as surface information like what the surface might feel like. This gives us more information about what this guy is like. Then we get to rigging, or the rig of the character. This is where we articulate these models with actual skeletons, much like a person like me needs a skeleton to move. If I didn't have a skeleton, I wouldn't be capable of moving around. I need the structure to help my muscles pull and flex. And so in order for our characters to pose and flex, we need a rig to help define our animation and create a final product. So now, instead of just a dead model in a T-pose, we have a little friendly green monster guy flying along, and we have a lot more information. This is how I want you to think about every element we're going to be working on in the class. It's all about storytelling, and it's all about information that we get. So like, what makes up a character? I think Overwatch is a great example because while keeping the same style, they have dramatically different looks to them. And so when you're thinking about creates a character, you have to ask yourself, in this moment, I'm looking at just the silhouette, and what do I see? Now, you can't really tell who these people are. You might say they're women. They're probably relatively young. It might be hard to tell where in the world they're from. What time period it is exactly. Maybe you can guess a little bit, but you see, without the surface like contact information, it's hard to tell more information. When I actually take away the silhouette and we dive a little deeper, well, now, okay, it's Mean Girls, because I love Mean Girls. It's a great movie. But now we know a lot more information about who they are. We also get a much better sense of their personalities. This is the kind of information that a T-pose, just the mesh, so to speak, of the characters can't give us. So a good character is a silhouette, it is a material which gives us detail, and it's a pose. And all of these things come together to give a sense of who someone is. So even though sometimes, I say all this because sometimes in the class, you'll be doing retopology and trying to make sure you have quads and good edge flow, all terms you're going to understand in just a couple of weeks. And you're going to say to yourself, hey, I got to figure this. But don't forget, it's all about storytelling. And it's all to a point. It's all to help communicate an idea. So there's three major kind of disciplines, I would say, in computer graphics art. And I'm going to break them down, overly simplified, but I want to break them down this way anyway, just to help you understand and wrap your head around it. There's generally things under animation. There's careers under sort of what I would call environment art, and careers under character art. What this kind of means is animation is anything that needs to get rendered or moves or illustrates with motion. An environment is anything large or holistic, something a person needs to be inside of, a location where something takes place. And a character is anything that we focus on. It could be a car or a gun in a Call of Duty game because it's a huge focal point. This is putting detail into something that is communicating the story or is an important part of what we're supposed to understand. So animation is everything from actually making the characters move and animate in a project to creating the rigs that are necessary to create the animation moving, or doing things like motion capture data and cleaning it up so that it can be used in a film or game. Everything in environment is modeling modular pieces to environment, to lighting environments, to creating materials on props. And in characters, we have everything from creating cartoony illustrated characters like you might think of as character illustration, to doing all the baking, texturing, and detail work on a hero prop like a motorcycle that our main character might be driving. So this is all part of the same thing and it fits together. When we're doing all of this, like I said, there's a lot of rules that go into 3D art, and I'm teaching you those because I want you to have the easiest time possible. The sooner you learn the terms, the sooner you learn all the rules, the easier time you're going to have. But at no point forget that 3D art is really just about telling stories with images that possess depth. That's all we're doing. And even though we do all this 3D work, we're doing all this lighting, texturing, modeling, it's still going to go, for the most part, onto a two-dimensional screen that gives us some sense of an image that's creating some sort of story that goes with it. So that's it for your introduction to what 3D is. In the next video, we're going to take a little tour through Blender and Painter's UI and help you understand a little bit of how it works.